All right, here are, excuse me, here are the answers to lecture lesson three's notes. This is what you did yesterday. You could have already checked these on my website. They were up there, but here's another check if you want to get those out and check. I'm going to go right ahead and assume you did them on the website, so you're going to need to pause the video now if you want to check these. All right, our main concept here in lesson four is simplifying composite functions. We're still working with composite functions. It's the same idea as yesterday. A lot of carryover from yesterday. A lot of this should make sense if you understood what we were doing yesterday. Simplifying composite functions. All right, a couple problems to get us started here. We're going back to expanding some things because this is going to be important for us in this section that we remember how to do this. Now, if I want to expand this first term right here, what I've got to do is I can't just distribute the squared. I can't distribute the squared. If I do, I won't get that. I'm going to walk over to the board here, so I might be a little quiet. Actually, I'll bring this with me. So I've got to rewrite this as, guess my smart ink needs to be on. Here we go. Okay, I've got to rewrite this as 2x plus 3 times 2x plus 3. And once I have it rewritten like that, I can go ahead and distribute everything. So I distribute the 2x to each thing, I distribute the 3 to each thing, and that's what some of you might call FOILing. We're going to get away from that word this year, but for right now, if you want to use it, if that's how you think about it, go ahead and do that. That's what you need to do in order to get this answer here. 4x squared plus 12x plus 9. It's a lot different than 4x squared plus 9, which is what you'd get if you tried to just distribute the squared. Can't do that now. All right, let's get rid of that. Okay, same thing down here at the bottom. One note I want to make right here at the bottom is that we've got order of operations again here. First thing we have to do is to do the exponent. So we need to square that term, x minus 5. So write it right beside itself and distribute it all out. And then, only then, are we going to be able to distribute the 4 into all of that. So we have 4x squared minus 40x plus 100. Okay, moving right along. Got two functions here, f and g. First question. There's the bell. First question asks for f of negative 5. So we're going to take our function f, and we're going to leave space, and we're going to plug negative 5 into that function. So we got negative 3 times negative 5 gives us 15 plus 4. This should be fairly straightforward. This goes all the way back to section 2, evaluating functions, just being able to plug in numbers, and we get 19. Pretty straightforward. All right, now this is like what we did yesterday, f of g of 3. So g of 3, we're going to need to get that so we can plug it into f. So I rewrite f, and I leave myself some space there, and then I'm going to plug g of 3 in there. So let's get g of 3. I do 1 minus 5 times 3, and I get a answer of negative 14. That goes in place of g of 3. Then I multiply to get 42 and add 4 to get a final answer of 46. So just like yesterday, a reminder, we work from the inside out. We have to simplify the inside first. Okay, look at another one. F of triangle. It doesn't matter if it's a number in there, if it's a variable, it could be a shape. F of triangle, we follow the same exact procedure. So negative 3, and then we leave space because we're plugging in for x. We're always plugging in for that variable since this was f of x. Now it's f of triangle, so triangle goes in place of x. And then negative 3 times triangle, well, that's just negative 3 triangle plus 4. Pretty straightforward. It could have been a variable, could have been a number, could have been a shape. Works out either way. Okay, f of x plus 2. So let's rewrite our function f, leaving space there to plug in x plus 2. Now here's where it's important that we do this, that we have those parentheses as well, because that's going to help us because we need to plug in x plus 2 into those parentheses. Now, I'm letting you know right now, this is the number one mistake that people make while doing this is that they'll just not put the parentheses and they'll end up with -3 times x and then just a +2 off on the side. They won't get this fact right here that the -3 distributes to both things. Remember that whenever we rewrite our function and leave space to plug in, that we put those parentheses so that we know that all of those operations that happen to x, since x was times -3, that stuff we plug in this case, x plus 2 has to be times -3 as well. Okay, so we go on and we distribute. We get -3x minus 6 plus 4. Combine some like terms to get -3x minus 2. So just to recap, what we need to do is leave space, take out every x in the function we're using, and leave space and plug in whatever's in the parentheses. Take out the x, leave some space, plug in whatever's in the parentheses here. All right, going on. F of g of x. So same first step. Let's rewrite f and leave some space right there. Then let's plug g of x in there, just like we've always been doing. Now, I don't have to just write g of x anymore. I have an actual equation that I can plug in place of g of x, that 1 minus 5x. So let's go ahead and do that. Instead of writing -3g of x, let's write -3 times the quantity 1 minus 5x. Important again that we have our parentheses. Number one mistake, don't make the number one mistake. Put these parentheses in whenever you're plugging things in. All right, so now we distribute our -3 to both the 1 and the minus 5x. We get -3 plus 15x plus 4. We combine a few like terms, and we get 15x plus 1. All right, a note. Write this down over there. You've got a section for note. F of g of x does not mean multiply f and g. It's not multiplying. We're putting one function into the other function. If I wanted to multiply these two functions, here, let me see if I can get my ink back up. If I wanted to multiply these two functions, let's go back. There it is. If I wanted to multiply these two, I would have had to write it like this. F of x times g of x. That would have multiplying the two functions. That's something entirely different from composing the two functions. What we're doing right now is composing the two functions, where we put one inside of the other. Okay, let's get rid of that. All right, so going on. Simplifying composite functions. Here's the real meat of the lesson right here. Here's what we need to learn how to do. So we have to do f of g of x for these two functions. So I've got to take f and rewrite it, leaving space wherever there's an x. Leaving space, a set of parentheses wherever there's an x. Now notice, this one is squared. This one is times 2. Those parentheses are important. Then I take g of x and plug it into both. So what I'm going to do is I've got something for g of x up here, the 4x minus 2. I'm going to take that and plug it in for each g of x. All right, now for simplifying this right here, this is why we did that warm-up. 4x minus 2 squared, can't distribute the squared. Going to have to write 4x minus 2 times 4x minus 2 and distribute everything all out, or FOIL it if you like to use that term. Over here, we're going to have to distribute the -2 to each term. So once we do that, this one here, 4x minus 2 times 4x minus 2, when we distribute the -2, this becomes -8x plus 4 and plus 3. Then when we go ahead and we distribute everything here, we distribute the 4x to each thing, we distribute the -2 to each thing, we're going to get all of this stuff, 16x squared minus 16x plus 4 minus 8x plus 4 plus 3, combine all of our like terms, and finally we get 16x squared minus 24x plus 11. So f of g of x is 16x squared minus 24x plus 11. All right, let's try the next one. G of f of x. So we write the function g, leaving some space to plug in, because we're going to plug in f of x now into the function g in place of every x. So I have something I can write instead of just f of x. I can write this whole thing, x squared minus 2x plus 3. Now, In order to simplify here, all I'm going to have to do is distribute the 4 to each thing. So I distribute that 4, and I've got 4x squared minus 8x plus 12 minus 2, and I combine my like terms, and there I've got my final answer, 4x squared minus 8x plus 10. So let's look at this bottom box here. Is f of g of x equal to g of f of x? Look at the two answers we got in the two previous boxes. Are they the same? Nope, they are not the same. Composition, where we compose two functions, we put one into the other, is not commutative. Commutative means you can do it in any order. Think of it this way. What is 1 plus 2 plus 3? Well, that's 6. What is 3 plus 2 plus 1? 6 as well. How about 2 plus 3 plus 1? 6 again. Does it matter what order I add 1, 2, and 3 in? No, it doesn't matter at all. Addition is commutative. We can do it in any order as long as we're just adding. Composition, however, the order matters. F of g of x is not the same as g of f of x. Changing the order will give you a different result. Hopefully you've written some notes down about what I've said and what's written here on the screen so that you remember that. Okay, last section. Watch out for constants. Okay, f of g of x. So we rewrite our function f, leaving space to plug in g. And we go ahead, we want to plug in g of x into both of those. And we look up there and, well, that's pretty easy. G of x is just 8. So we're just plugging in 8 for each of those. F of g of x, and then we just have to do some algebra. 8 squared gives us 64, minus 2 times 8, so minus 16, plus 3, and we simplify that, and we get 51. So same process, only it was a lot easier because we were just plugging in 8. All right, next step here, g of f of x. So we write our function g, leaving space wherever we find an x. And where does the f of x that we're trying to plug in now go? What do you think? Nowhere. It goes nowhere. There's no space to plug it in. G of f of x is just 8. We plugged in f of x everywhere we could. There was nowhere to plug it in, so we're fine. We're done. We don't have to make up new spots to plug it in. We only plug f of x in wherever we find x in that g equation. If there's no x's there in that g equation, we don't have to plug in f of x. All right, so g of f of x just equals 8. All right, I think that about wraps it up for these. I think that's the end here. Yep, we're back to the very beginning with those answers. Okay, so what I want you to do then is to finish up the homework that goes along with this. For the homework, you can check the answer key is on my website. You'll be able to check your answers there. Please go ahead and do this. This is a super important skill. Composition of functions is one thing that I think helps out a lot, especially when you get to calculus. You can use composition of functions. You could ask some of the students right now. All right, finish up that homework. Check the website for the answer key.